rational functions that have more than one asymptote. They can have more than one vertical asymptote. We can have something called a hole, all different kinds of things we call discontinuities. So go ahead, you want to take out your notes. We are going to use the graphs in a few minutes, but if you wouldn't mind just going ahead and keeping those pens closed up, I'll tell you when we're going to use them. But it's good maybe to have even different colors at your table. It looks like we have red and green and black. That's good. You might want to share colors, which will be fine. Chris, could you put your phone away for me, honey? You are going to need some notes today, so if you would take your notes out, there are several key things you're going to want to write down about asymptotes and how to find them based on the equations today. Okay? So we are dealing with this unit called rational functions. Rational functions simply mean where is the x in the equation? Where has the x been in all the problems we've done up to this point? In the equation, where's the x? Is it in the numerator, in the denominator? Is it in parentheses? Is it under a square root? Where's the x? In the denominator, okay? So we're still going to be dealing with, this was kind of our parent, we called it the reciprocal function last time. It's just simply the x is in the denominator, which implies we have some vertical, some horizontal asymptotes, possibly a hole even. So let's go ahead and kind of do a little bit of review. Let's remind ourselves what a polynomial is. Polynomial, it's a big word. Can I name it by its degree? What's degree? Let's remember all these terms, all these snow days have kind of harbored us here a little bit. Okay? Get your homework. You can get it put on my desk for me, okay? What's a polynomial? And what's a degree? More than one? Well, a degree could be more. What do you mean by more than one? Some of them have more than one term, but some of them only have one term. Monomial, binomial, trinomial. We know those things, right? The number of terms. What do they mean by degree? Which one? Not necessarily the first one, but the highest one, right? In standard form, it is the first one, right? But it's the highest power is the degree. So we can call it a quintic trinomial. We can do that with the degree, right? We know that. So that's a true statement. Maybe. How about the second one? A polynomial with more than one term is called, I'm sorry, with not more than one, but just with one term, is called a binomial. True or false? False. What is it called? When it's more than one term, or when it's just one term, what is it called? A monomial. Good. Okay. So how many terms does a binomial have? 2. Okay. So we know these things as a review. No big thing. But we're not going to really be dealing much with polynomials so much today as we're going to be dealing with rational, which means that the x is in the denominator. Okay? So let's talk for a minute about what it means to be discontinuous. Again, not necessarily something you need to write in your notes, but we just need to make sure we have a frame of reference and we know what it means. When you graph something that is discontinuous, it contains gaps. There might be a hole. Can you think of something we've already graphed that would be discontinuous? Anything. How about, let's start with something we really know. How about a parabola? Is a parabola a discontinuous function, a quadratic? Discontinuous, or would it be continuous? If I graph it with my pencil, do I ever lift up my pencil at all? No. So it's a continuous function. Actually, any polynomial, whether it's quintic, quartic, cubic, quadratic, they're all continuous functions. When we start to think about gaps, holes would be a point of discontinuity, which is something you have here. It looks like it might be a cubic function, but it has a hole in it. Okay? And that hole is something important. We'll talk about how to find that in a few minutes. But points of discontinuity, anything from a hole or an asymptote. Okay? An asymptote is a place where something is discontinuous. You have to lift up your pencil and put it back down to draw the other part. Okay? So let's look at these 3 pictures. Let's decide if they're continuous functions or discontinuous functions. How about number 2, Bradford? What do you think? Continuous or discontinuous? Because you have to lift up your pencil, right? So there is that asymptote right in the middle. It's not drawn, but you can kind of imagine that being an asymptote there. So it is a discontinuous function. Good. How about number 3, Kimberly? What do you think? Yeah, I don't have to lift up my pencil. It's a continuous function. How about number 4, Daniel? What do you think? Do I have to lift up my pencil ever? And number 4? Yeah, I got a hole there, right? So because of that hole, you want to make sure that you know that that is what's called a discontinuous function. Holes, asymptotes, discontinuous. Good. Now, a little bit beyond our level right now, this is just a notation. This f of x equals a is continuous at a certain point. We talk about something called a removable discontinuity. That just means a hole. So if you can remove it and put it back in, that just means a hole. It's called a removable discontinuity. Okay? These big fancy words. All right. So how do I find them? This is what we need to be thinking about. Okay? There are, like we said, 2 kinds of discontinuities, holes and asymptotes. How many kinds of asymptotes are there? What are they? Tell Alex, because Alex wasn't here last class, and neither was Alexis. And they need to know what are asymptotes and how do I find them. Neither was Chris. What are asymptotes? Help us out. Maria, what's an asymptote? Do you remember? How do I draw them? It's like an imaginary dotted line. We call them guidelines, right? They guide the graph. And how can I draw them? Which ways can I draw them? Vertically and horizontally, okay? There are also others called slant asymptotes that you would learn in a different class, but for our purposes, we have horizontal and vertical asymptotes, okay? So let's look at one particular function here. I want you to graph that on your calculator, okay? So y equals 1 divided by x squared minus 16. Take a second, Christian. If you don't have your calculator, make sure you go check your calculator out. And let's actually graph that. Okay, so if you don't have yours, you need to get yours. And we're going to graph this function. Plug it into your calculator. Yeah, I definitely see more than 1. So remember, if we go to alpha y equals, numerator, denominator, we can type 1 on the top, and then we would just say x squared minus 16. You might need to zoom standard just to be able to see here. It's kind of hard to see what that even looks like, okay? The calculator sometimes is really good at seeing things, and sometimes it's not so great at seeing things. Asymptotes do not show up on the graph, okay? Here's one of those cases where it's really kind of hard to see what's going on. But I'm going to show you in a graph really what is going on, and you're going to have to do this on your graph paper here, okay? So, first of all, we want to decide what our domain and range are, okay? What could x be? What could y be? And those domain and range values are found by either the holes or the asymptotes, okay? So, we want to figure out where the function is undefined. That's going to help us decide the domain and the range. So when you have a function like this, what would make it undefined? I know things like I can't have a negative underneath the square root, and I can't divide by 0. What would make that happen here? Do I have any square roots to worry about? Chris, do I have any square roots in my equations to worry about? Any radicals to worry about? No. But I do have a fraction. So I need to worry about dividing by 0. I don't want to do that. So what would make x squared minus 16, you take your entire denominator, equals 0? Okay? So this is something I would write down in my notes. I would write the problem that I've highlighted. Y equals 1 over x squared minus 16. And I'd like for you guys to go ahead and set the denominator equal to 0. That happens in any rational function because that's where the asymptotes are going to happen. So I want you to get your notes out, sweetheart, and write this down, okay? So how do I know something about that x squared minus 16. It looks familiar to me. What kind of a function is that? Isn't that just quadratic? Do I know how to solve x squared minus 16? Oftentimes, we're going to be factoring, okay? So I want to think about all the different ways we can factor, because we're going to be doing a lot of factoring over the next couple of class periods. How do I factor x squared minus 16? It's x minus and x plus. Do you remember the pattern? What number goes here and here? 4. It's a difference of perfect squares. Okay? So when I set the first factor equal to 0, I get a positive 4. When I set the second factor equal to 0, I get a negative 4. Those are places of discontinuity. Those are where the vertical asymptotes are. The vertical asymptotes are at 4 and negative 4. Look back at your calculator. Do those show up on your graph? Do you see a dotted line on your calculator at 4 and negative 4? I don't. What I'd like for you to do on your whiteboard that you guys all have is go ahead and make sure that you have it arranged correctly, which means that the writing is on the bottom, okay? And I want you to draw vertical asymptotes at 4 and negative 4. So go ahead and draw those in. If you need a ruler, feel free. I gave you all one for Valentine's Day. I know you keep that in your back pocket at all times. But if you want to borrow a ruler, that's okay too. But go ahead and draw those vertical asymptotes at 4 and negative 4. I want to see them. I want to see the dotted lines. So at positive 4 and at negative 4, draw a vertical line with a dotted line on your whiteboard. These vertical asymptotes are not removable. They're not holes. We'll worry about holes in a few minutes. But there are 2 vertical asymptotes here. Vertical asymptotes happen where the denominator equals 0. Sometimes you have to factor it in order to figure out where those are, which is what we had to do here. Okay? They are non-removable, which means they're asymptotes. They do help us tell me what the domain is, okay? Whenever you have a point of discontinuity, like an asymptote or a hole, those are called domain restrictions. So if I had to tell you, or if I asked you a question on a quiz or a test, what is the domain of this function? The domain of this function is all real numbers except 4 and negative 4. X can be anything except 4 and negative 4. Notice if you go to the table on your calculator. Go ahead and do that for me. Go to the table. What do you notice about the table? It should say error. You didn't get an error on your 4 and negative 4 when you went to table? I got an error at 4. And if I go to negative 4, I also have an error. That should happen. The errors happen where I have asymptotes or where I have holes. So those are another way to double check that I did it right. Okay? All right, we're halfway there. We have at least our vertical asymptotes drawn. Now, there also happens to be what we call a horizontal asymptote here. It's a little hard to see in the graph, but there is y equals 0 as a horizontal asymptote. So do me a favor, across y equals 0, draw that horizontal asymptote across the middle there. I want to see that with a dotted line as well on your whiteboard. Okay? Make sure you're using a dotted line and not a solid line because those are guidelines. Anything dotted is not to assume to be part of the graph. So we've kind of broken up your graph into sections, okay? And so here's where we're going to fill it in. The calculator a little bit helps you, but it's kind of hard to see the way it's drawn. If you notice up here on the left-hand side, this little quadrant, this little part of the graph up here, we have part of our rational function. So I'm going to borrow Luis's if he doesn't mind. And I'm going to show you, you need to add up here between these dotted guidelines your part of the graph. So do me that favor. Go ahead and draw that in right here. Draw this part in the top left-hand part of your graph. Draw this in right here. Use these guidelines. So you're just drawing it in. It's hard to see on the graph, on the calculator, but you're going to draw it in here. Okay? So go ahead and take a moment to do that for me. I want to see that part drawn on your graph. You draw it right here because you use these as your guidelines. Okay? So draw right here. So just draw the graph. So just draw this piece right here. Okay? So Alex, draw that piece right there. Not here. Okay? All right, good. Now, if you look at April's, she used the guidelines, that's fine. The graph is really a little bit closer to the dotted lines since you have it drawn. I don't think I'm going to count off for that necessarily, but just so you know, it's a little bit closer, okay? Daniel, can I use yours real quick? His looks a little bit more closer to the lines, really showing it as guidelines there, okay? So when I'm grading a graph on rational functions, you have to have the correct asymptotes, and then you're going to place the pieces in the correct parts, and that will be fine. Both of you would have gotten credit, okay? Now, there are more pieces to my graph. If you notice in the middle section between the two vertical asymptotes, I have kind of a U shape down here. Okay? It's kind of hard to see, but there is a U shape. So what I'd like for you guys to do is in between here, if you notice Gabby's graph, down here, just create a U shape down here. Use your guidelines. Use your horizontal and vertical asymptotes to kind of guide you down here at the bottom. But draw that bottom piece in as well. Excellent, Christian. Good job. I'm sorry, honey? Yep, it's close to the line. That's perfect. I'm going to borrow Alex's. Alex's looks great. If you look here, he's got his left piece and his middle piece of his graph drawn in. Yours should look very similar. Okay? Looking good so far. Thank you. And then the last piece, Joseph's already done it. You can see up here in the top right part of the graph, we have yet another piece to our function. Okay? So you have 3 total in this particular case. Okay? Great job. Good. Good. You probably should put arrows on the ends of the graphs just to indicate that they do go on forever. In the middle part, they do go on forever downwards, etc. Okay? But this is an example of a more complicated rational function. Okay? How did we find the vertical asymptotes? Remind me again. What did I do? What did I do to find the vertical asymptotes? I factored what? The denominator. Okay? So let's keep practicing. Let's look. The horizontal asymptotes are a little bit more difficult to find. Okay? So here's what you need to write down. Vertical asymptotes are where the denominator equals 0. Okay? So you have to find those. Step 1. Okay? Vertical asymptotes are where the denominator equals 0. You don't have to write the whole thing. Vertical asymptotes, denominator equals 0 is good enough. Sometimes there are things called holes, and we'll look at how to find those. Hang on. I'm going to write this different. So 1, we can have a vertical asymptote. 2, we can have possibly what we call a point discontinuity or a hole. And that is where a factor on the top and a factor on the bottom cancels each other's out. So a hole is where we have a factor on top and a factor on bottom. So a factor cancels out. Okay, a factor in the numerator and the same exact factor in the denominator. That's where you have a hole, and we'll look at that where that happens in a few minutes. What, baby? It's written on the board. Vertical asymptotes are where the denominator equals 0. Holes are where the factor is on the same on the top and on the bottom. Which I said the word factor, which means we're going to be doing some factoring. Okay, so we're going to need to get used to that. It's the horizontal asymptotes that have some rules to it, where we're going to have to really pay attention. But holes and vertical asymptotes help with the domain. Let's write where the horizontal asymptotes. It's the blue chart. Okay? So I'm going to pause the recording for a minute, put in attendance. I want you to copy the blue chart into your notes. Horizontal asymptotes is what we're looking at here. Okay? And there are some cases. It's talking about the degree of the numerator and the degree of the denominator. Okay? So we have degree of the numerator, degree of the denominator. So copy that into your notes for me real quick. If the m's and the n's bother you, you can also write them with just you can use the words top and bottom. We're looking at the degree. Okay? So if the top degree is less than the bottom degree, then there is a horizontal asymptote at y equals 0. The degree of the bottom is bigger than the degree of the top. Did that happen in the one we just did? Let's go. I'm gonna come back to it, but let's look at the question. What is the degree of the bottom in this problem? What's the highest power in the bottom? 2. What's the highest power in the top? 0. There's no x. Would you agree? So is the degree of the bottom bigger than the degree of the top? Yes. That is why you have a horizontal asymptote on your picture that you drew at 0. Okay? Because the degree of the bottom was bigger than the degree of the top. So the example we just did fit that bill. Okay? There are other kinds of asymptotes. If the degree of the top is bigger than the degree of the bottom, there is no horizontal asymptote. Okay? And that happens sometimes. Sometimes there's not a horizontal one. There's no horizontal asymptote. If the degree of the top and the bottom equal each other, then we have a special case. If the degree of the top and the bottom equal each other, you have to look at the leading coefficient. And it's just the leading coefficients over each other. Y equals A over B. We'll look at an example of that in just a minute. But in order to figure out the horizontal asymptotes, you have to look at the powers, the highest powers, or the degrees of the numerator and the denominator, and then you look at where those come from. The calculator is a great tool, but as the example that we just showed you, it doesn't provide all the information right from the picture. So sometimes you have to be a little smarter than the calculator to figure out where they go. Okay? So we're going to use the calculator, and then we'll work as a tool, but you still need to know the information on how to find it. Okay? Okay. So let's look at one where we have to check for holes, we have to check for vertical asymptotes, horizontal asymptotes, etc. Let's look at this example. Okay? Again, it's something I want you to put in your notes. Go ahead and erase your boards. We're going to do this one on our whiteboards as well to make sure that we have a nice picture of what we're looking for. Okay? So this is the example that we're going to be doing. It is already in factored form, which sometimes is helpful. If it's not in factored form, you will have to go ahead and do that, all right? So this is like one step that we can eliminate, the factored form, okay? So the first thing we want to check for, well, let's just write the steps down. If it's not in factored form, you need to factor it. So step 1, we're going to factor. It's already factored, so we're going to go ahead and move on to step 2. Okay? Step 2 is going to be to check for holes. Are there any common factors in the numerator and denominator here that could possibly cancel out? Is there an x plus 4 in the bottom? Look at the picture. No. So this is a particular function that has no holes. If there was a common factor on the top and the bottom, there would be holes. But there's not here. So we've checked for them. We don't have any. We'll move on to step 3. Step 3 is going to be to graph the vertical asymptotes. I'm going to abbreviate that with the V and the A. So you have your whiteboards. Where do the vertical asymptotes go on your whiteboards? Where do they go on the graph? Perfect, April. It's where the denominator equals 0. So it's where x minus 2 equals 0. It's where x plus 3 equals 0. So the signs are opposite. So the vertical asymptotes are at positive 2 and negative 3. Go ahead and draw those in on your whiteboards. Vertical asymptotes. Okay, these are your vertical asymptotes at positive 2 and negative 3. Step 4. Once we've put our vertical asymptotes in, what do you think we're going to do next? Horizontal asymptotes. And horizontal asymptotes are found by looking at the degree of the numerator and the degree of the denominator. When it's in factored form, it's a little harder to see exponents. So we're going to count the number of x's. How many x's are in the top on the numerator? 1. So the degree of the numerator is 1. How many x's are in the bottom? 2. So x times x would be x squared. So the denominator is bigger than the numerator. The degrees anyway. So what does that mean? Look at your chart. When the degree of the bottom is bigger than the degree of the top, what kind of horizontal asymptote do I have? Shamar, what kind of horizontal asymptote I got? Look at the chart you wrote down. The degree of the bottom is bigger than the degree of the top. Y equals 0. Okay? So in that case, we know that the degree of the numerator was 1. The degree of the denominator is 2. Therefore, the horizontal asymptote is y equals 0. So I want you to draw the y equals 0 asymptote across on your whiteboard. This looks very much like the first one we did. Okay? It's not exact, but it's close. The asymptotes are in a little bit of a different place than the other ones were. Now we have to figure out where the pieces, Natalia, put your head up, honey, where the pieces of the graph go. Here is where, on step 5, I'm going to call it, I'm going to say use your calculator to fill in the pieces of the graph. Okay? That's what I want you to do. Fill in the pieces of the graph. So go to your calculator and let's plug this in. It's already in factored form, which is helpful. Go to y equals. Clear out what's there. The numerator was x plus 4. The denominator was x minus 2 and x plus 3. And I'm going to have you guys go ahead. I'm going to pause the recording. I'm going to come around. I want to see your filled in pieces. So Chris, you need to be plugging this into your calculator. If I hit the graph button, sometimes it's a little hard to see what's happening. I think the middle part's a little easier. The left-hand side's a little hard to see what's going on. Would you agree? So sometimes the table is helpful to see what's happening. If I go to the table and I go here to the negatives, notice what you see, okay? I have getting smaller and smaller and smaller. Do you agree? It continues to go out that direction. So that simply means that the graph does continue in this direction and this direction, okay? It goes forever. So, doesn't stop. Yes. Yes, good. Excellent. Okay. Good. Daniel, did you get one? Good. All right. One more. Anybody else? One more before I put them away? Who else got it graphed? Let's see this table over here. I'm missing one piece over here. Good. Did you get yours, Carolina? Yep. Good. Good, Matthew. All right. So let's try another one. Yep. All right. So let's try another one. Maybe we should try one that possibly would have a hole in it. I don't know. Go ahead and erase your boards for me. Let's try one from scratch and see if we can graph the function. Okay? Let's try one where we might have to actually factor it first. I want to try a different one. Sorry, I want to try one that some different things are going to happen. Let's try this one. Let's try this particular function, okay? So this is our another example that we're going to do here. Erase your boards, okay? And we're going to figure out here our steps. So the first step, if you look at the steps I wrote down before, they were step 1, factor. Is this already factored? No, so you need to do that. Factor the bottom. I think I might have made one that's not factorable. Sorry. Let me change it. That look a little better? Okay. That should work now. Still not. There we go. Okay. Sorry. Now it's factorable. X minus 4, x plus 2. So when we factor it, we get x plus 2 in the numerator, still there. And the denominator factors to x minus 4, x plus 2. Remember, the two numbers when we factor have to multiply to be negative 8 and add to be negative 2. That would be negative 4 and positive 2. Do you agree? All right, they add to be negative 2, multiply to be negative 8. So what do you notice about my factor? The second step would be to check for holes. Do I have any? I do. Because I have a numerator, the numerator has a factor that's common with the factor in the denominator. So that's incorrect what you're doing, Christian. You need to pay attention to what I'm doing. Because I can cancel out this factor and this factor, that means there is a hole at x plus 2 equals 0. So we're going to write that over here. A hole where x plus 2 equals 0. In other words, at x equals negative 2, there's a hole. And we'll have to put that on the graph in a few minutes. Okay, it's not there yet, but we'll put it on the graph. Once I've canceled it out, let's go ahead and figure out what the equation is still left. The equation that's left is 1 over x minus 4. Do you agree? The numerator canceled out, so I have a 1 up there. And my denominator is now x minus 4. It's whatever factor is left. Okay, what was step 3? By the way, that should look familiar to you. Does that look like what we had last night for homework? Isn't that a reciprocal function that's moved to the right 4? Okay, so let's go ahead and look at step 3. Step 3 is to do what? Vertical asymptotes. And how do I find those? Vertical asymptotes happen where the denominator equals 0. In this case, I only have one place. So x equals positive 4 is the only vertical asymptote. So draw that on your board. X equals positive 4. You have one vertical asymptote. Sometimes you have 2 or 3. Sometimes you have 1. It just depends. Okay? So we have our vertical asymptote. What's step 4? What's step 4? Horizontal asymptotes. So I'm going to be looking at the degree of the numerator and the degree of the denominator. You can do it at the beginning or at the end. It doesn't really matter. Let's do it from the beginning. The degree numerator, 1. The degree denominator, 2. The bottom one's bigger, which means the asymptote happens at y equals 0. We'll do one in a minute where it's not 0, so I can just show you what it is. So draw in your horizontal asymptote at 0. Now we're going to use these guidelines, the new asymptotes, one at 4 and one at 0. So we have horizontal asymptotes at y equals 0, vertical asymptotes at x equals 4. That's what your graph should look like. Now we're going to, step 4, I use the actual calculator to fill in the graph. So plug it into your calculator, plug in the original one, always the original one. So we're going to plug this guy in. Plug it into your calculator and see where the pieces of the graph go. We should kind of have a good estimate that it should look something along these lines. Or no? Yes, no? I don't think so. So use your calculator. Don't guess. Where do the pieces go? Should go here and here, just like the reciprocal function that we noticed. So I want everybody to draw it in. We are not finished, though, so be careful. So I want to see it on your boards. Once you have this, you need to be careful because we're not finished. Because we had a hole. We had a hole at x equals -2. We have to go back and put the hole in the graph. So I tend to use a different color, but you can use whatever you want. If you want to switch colors with someone at your table, feel free. Otherwise, it's fine to use the same one. Doesn't matter. And I'm going to go where x equals -2. So -2 is here on the x-axis. And wherever the graph is, I'm going to put a hole right there. So I want to see everybody put a hole on their whiteboard where x equals -2 on the graph. Good. Erase it with your finger and just put a circle. That's going to imply that there is a point discontinuity, which just means a hole, in the graph there. Okay? So on the graph itself. So not on the asymptote, but on the graph itself. Okay? Good. Good. Perfect. So we know how to go back and fill in the holes. So this doesn't come this way. It just goes straight down there. Okay? Good job, Chris. Good. Good. Perfect. Awesome. So the same 5 steps every time. Factor, check for holes, vertical, horizontal, and then graph. So let's try one more. Let's see if I can figure out one that's going to have a different graph. So let's look at this one. Last one we're going to do, okay? Y equals x plus 3. All right, let's try this one. This one's a little bit more complicated. Okay, so a lot more stuff going on in this one. This will be the hardest one we do. Okay, think about your steps. A little bit harder to factor this one. Do we remember how to factor something with a leading coefficient of 2? Can't subtract everything. We're thinking about the two numbers that multiply to be 6. Where'd the 6 come from? 2 times 3, good. And adds to be 7. What numbers are those? Which one? 6 and 1, good. So what do I do with that 6 and 1? I rewrite my middle number, remember that? So it's going to be 2x squared plus 6x plus 1x plus 3. And I group. Very good. Group the first two, group the last two. Take out the GCF. I know I have to have an x plus 3 over here. I already do. So what number goes in front of the parentheses in the second grouping? A 1. So my two factors are 2x plus 1 and x plus 3. So a little bit harder to factor that one. Check for holes. Do I have any? I do. Okay, where's the hole? So the hole is going to be where the common factor cancels at x plus 3, right? So I have a hole where x plus 3 equals 0, where x equals negative 3. Good. My equation that's left is that. What's the next step? Vertical, okay. So vertical asymptotes happen where the denominator equals 0. What's that? Negative 0.5. Can you have a fraction? Sure. All right, how about horizontal asymptotes? Are there any? How do I check? Degree. So the degree of the top, highest power is 1. Highest power of the bottom is 2. What's a horizontal asymptote? All the ones we've looked at today are 0. They're not always 0. So I'll show you one and just show you one that wouldn't be. All right, and so we're going to graph. I'll just graph it real quick. Just you don't have to graph the whole thing if you don't want to. But we have, let's see, at 1, 2, 3. So at negative 1/2, we have a vertical asymptote. We have a horizontal asymptote, and then we're going to graph the thing. So graphing it looks like this. We'll use our calculator if we needed to. And we're going to go back and put a hole in at negative 3. Okay? And that's really all you would do. If you wanted to see something, for example, like this problem. Where are its horizontal asymptotes? Horizontal asymptotes. First of all, neither of them factor, okay? So I can't factor either the top or the bottom, so there's nothing to cancel. I could find the vertical asymptotes. They're at square root of 3 and negative square root of 3, whatever. How about the horizontal asymptotes? What am I looking for? The degree of the top and the bottom. What do you notice about the degree of the top and the bottom in this case? They're both the same. They're both 2. When the degree of the bottom and the degree of the top are the same, the horizontal asymptotes happen where the coefficients are. What are the coefficients here? 2 and 1. So the horizontal asymptote happens at 2 over 1, or just y equals 2. which means up here at 2 is where you'd have your horizontal asymptote. Okay? So when the degrees are the same, you look at the numbers in the front. Okay? That's going to help you. All right, I have some problems for us to work on. If you would kindly dry erase boards, erase them. Go ahead and put everything back up here. Markers back in the bag. Erasers back in the bag. And I'll pass out what I want you guys to work on, okay? You guys, real quick, over the snow days, you got a text from me if you were part of the Remind, if you've signed up to be part of the Remind app. I have officially assigned you guys an SOL review between now and spring break. You have between now and spring break to complete what I call 2 benchmark tests, and I want to show you where those are. You're going to log in to pearsonsuccessnet.com, okay? If you don't remember your login or password, we'll clear that up in the next 20 minutes, okay, before class ends today. Oh, look, you found it. Interesting. So what you do, once you log in, okay, you're going to click on this little to-do button. When I click on the to-do button, hang on one second. Let's try it again. All right, when I click on the to-do button, delete, there we go. All these things are going to show up, okay? You do not need to do all of these. These are really a review. It's a good idea to try some of them. Let me just click on one so you can see. If I click on the first, chapter 4, I'll just click on it, okay? And some questions are going to come up, and there's lots of them. I'll just pick one, exercise 8. Here it goes. And a question will come up, and it says solve the quadratic equation, okay? It says by completing the square, but we don't know how to do that, so you can just solve it any way you want. I'm going to type in an answer. I can type in radical answer if I wanted. Let's just type in the square root of, and I'm going to type in a 2, okay, just to see. I know that's wrong. I do know. We'll go ahead and check answer. Oh, sorry. And it tells you how to solve it, okay? You can view an example. It tells you what to do. You can get a hint. Goodness gracious. So you can get a hint. Help me solve this. It will give you a hint. So there's all kinds of different things you can do, okay? So I want to, I can look at those. Let me clear this one out. There we go. Anyway, all these exercises, you can go through any of them, and it will do the same thing. Have another question. It says plot the complex. Some of these you don't know how to do. We don't know how to graph complex numbers. Most of them you will know how to do. That's one that you might not. That's okay, though. All right, so anyway, so we're here. So what I want us to do from this point, we'll go ahead and close this. If you go, you can practice on these. If you go to the next one, these last 2, the Virginia benchmark tests 1 and 2, are the ones that are required, okay? So Virginia benchmark test 1 and Virginia benchmark test 2, these will be grades. The other ones, I can't see if you do them or not. They're really for you to practice. I would recommend that you go through them. But again, you have to click on the to-do tab, and you have to go to page 2 to do your benchmark tests. They're automatically graded, and they're sent to me. So you have until April 6th, which is the end of spring break, to complete it. If you have connectivity issues at home, we have a computer lab here at school. Starting next week, the activity bus runs Monday through Thursday. Okay? So you have an opportunity to stay after school anytime starting next week to work in the computer lab. But these 2 benchmark tests need to be done. Notice the due date, April 6th. It's the last day of spring break. Okay? Yes? Okay, so we'll set you up today. Okay? If you don't have an online account, you have to have one today. Okay? So we'll get that done. All right, any questions about this? All right, so you go ahead and continue working on the assignment I gave you. I wanted to make sure I give this to you. If you finish what's done in class today, you can get started on this at home. Okay? But if you need an issue with the textbook or you have an issue and you need to sign up for an account, come see me at my desk and we'll take care of that. Okay? Uh-huh.